Welcome to our video on using the lift-off gain compensation on the WeldCheck Plus. So first of all, looking at the configuration, we have a lift-off gain menu. If we go into that, we can see 4 settings. The max height, which is the maximum screen height you'd like the defect to reach. We have a max paint thickness and a min paint thickness. Optionally, you can have an alarm box that will indicate when the paint thickness is not within that area, and then number of points is configurable. 5 is the maximum and will give you a better signal and more accurate readings. So from there, go to the real-time screen. I've programmed the top blank key here with the lift-off gain function. So push that to begin. So I'll take my probe onto my test block, find a good piece away from a defect, and balance. Okay, lift the probe back on. Now go over the 1mm defect. Okay, so return the probe next to the 1mm defect, and the instructions: press function when probe is on test block by 1mm defect. So I press the red LEDs indicate nothing's happening. Push the button, so now it's looking for a peak in the signal. So I go over the defect and stop. Success. Now for the first shim, and as it says, repeat with a 0.5mm shim, which is what I've just added. Put that back and repeat. So start looking over the defect and stop. Next shim, 1mm. Record, over, stop, 1.5mm, and stop. Last of all, 2mm of shim, record, slide, stop. Now it's configured. So the first check to do is to check that the millimeter lift off here is roughly correct. So 2mm shim, 1.90, 2.03. Without shims, very close to 0. So now we can see the use of the paint alarm. If I have 2 shims, 1mm, or about 1mm, we're just inside the safe zone, which we set up as between 1 and 1.5. If it's below that, if the paint is too thin, we have an alarm condition. Or if I have 2mm of shim, where we're outside of the paint thickness area, we have an alarm condition. So let's get close, there we go. We're safe, just over a millimetre. So okay, now going over the defect, so this side, we have the defect is reaching this line here, which is the 40% point. With the shim, you can see that it's going slightly high. We can sort that out in a second. The reason for the signal going high is, as you can see, without a shim, the balance point is at the origin. With a shim, it suddenly starts to go high, which is an unfortunate real-world situation. So we can balance just the defect channel with the bottom balance button. So now we can see as we go over the defect, we reach this line here. And as I vary the number of shims, the defect's height is pretty consistent. But unfortunately, it will be out without a shim as we had to rebalance. So there we go.